Pleasant day, everyone. We are the group from BSIT1C, and today we're going to discuss some of the topics from our subject IT 103 or Data Structure and Algorithms, which is about abstract data type. But first, we would like to introduce ourselves. We are the Paro Paro G, and I'm Nazal Angelo R. Asuncion.
And I'm Sarina Joy Panyo.
And I'm Janeline E. Macarilay.
And I'm Michael Angelo Del Prado.
And I'm JP Geronimo.
And I am Sean Bryant Navarro.
Thank you very much. And now let's proceed to our first reporter, Ms. Sarina Joy Panyo.
What is abstract data type? ADT is a class of object whose functionality is specified by a set of values and a set of operations. It just specifies what activities are to be performed, but not how these actions will be conducted out. So it is a mathematical model for data type. It may be defined as a class of objects whose logical behavior is defined by a set of values and a set of operations. Arrays, list, map, queue, set, stack, table, tree, and vector are the example of ADTs. Next slide. So abstract. It does not specify how data will be organized in memory and what algorithms will be used for implementing the operations. It is called abstract because it gives an implementation independent view. The process of providing only the essentials and hiding the details is known as abstraction. The user of data type does not need to know how data type is implemented. So users only need to know what a data type can do, but not how it will be implemented. ADTs are extension and modification of the traditional concept of data type. The abstract data type can protect the data representation from direct access by other parts of the program. An abstract data type defines not only a data representation for objects of the data type, but also the set of operations that can be performed on objects of data type or objects of the type. Next, Sean.
Hello, Sean.
JP po.
Hello, and ito po yung how data looks like. And based po dito sa nakita niyong picture, ito po yung application program. Ano nga ba ang application program? Ito po yung computer program whose primary purpose in retrieving information from a computerized database. And nakikita niyo po dito is interface. And ang next po niya is parang kunyari, ito po yung data, yung application program, sabay dumadaloy na siya papunta dun sa abstract data type, yung publication function and private function, and dumadaloy naman siya papunta na sa data structures, and meron po siya dun array and linked list. And kasi po ang ibig sabihin po ng interface dito sa ADT is siya yung nagko-combination of data together with its method is called an ADT. Next.
Example, the user of a data type does not need to understand how that data type is implemented. For example, we have been utilizing primitive values such as int, float, and char data types only on the basis that they may operate and be performed on without understanding how they are executed. As a result, all a user needs to know about the data types is what it can accomplish, not how it will be executed. Consider ADT to be a black box that contains the data types, underlying structure, and design. So, for example, we have been utilizing primitive values such as int. Kung gagamit ko po ng int, float, and char data types, kung yan lang po ang gagamitin mo, it's basis lang po siya, and mapaperform mo po siya ng kahit di mo siya maintindihan kung paano siya in-execute or ni-run. So, as a result po, dapat alam mo rin po kung ano yung ma-accomplish niya or magagawa niya. And yung hindi kahit yung hindi lang po yung kahit yung pag-execute or na-run niya yung alam mo. Dapat alam mo din kung anong na-accomplish niya. That's all. Next.
We will now define different ADT or abstract data types. List, add, stack, add, and trace ADT. Based on what you see in this picture, these are different types of ADT or abstract data types. The first is a list. The list is that it has its own components, and the second is a stack. It is a linear data structure, and the third is trees. This is the unified connect data. So that's how it is in the it's in the picture, and the other four are linked list. This is the ordered collection, and the other five are queues. This is the network buffers, and the last one is hash map. This is the one that converted of the set of data. Next.
So now let's explain about list and list ADT or abstract data type. Lists hold reference to their contents in a contiguous memory block, while linked lists store reference as part of their own components. So nalabanggit na natin dito yung linked list, but we're talking about list. So list used to store data type in a sequential manner. So here in our example, we have our head structure, which is the count, and our compare function. Compare function is used to compare data type to the list. And yung head, ito pointer and where, these are the nodes. So what are the nodes? What is node? Node is a data point in a larger network. Okay, so take note, node is a data type in a larger network. So these are the node of our list. Another example, we have here our list. This is a basic example lang. So our list is 1, 2, 3. So if we print our my list, it will the output will be this 1, 2, 3. Next is about linked list ADT. So similar lang siya, medyo similar lang siya sa ating list ADT or abstract data type. Ang pinagkaiba lang is linked list are elements that are linked from each other. So again, like array, linked list is a linear data type. Unlike arrays, linked list elements are not stored at a contiguous location. The elements are linked using pointers. Because yung link po, yung list, nakastore siya in a contiguous manner. Yung location or manner. Pero yung linked list, link lahat ng element natin. Nalalaman na lang natin sa name niya. Linked list. So again, example natin sa linked list is GitHub. Kasi meron tayong head, which is our first node here. Ito. This is our head, yung first node natin. And then, itong next natin, node na lang ang tawag natin dyan. And magiging null na lang to if wala nang data yung ating block. And these arrows naman, tawag natin dyan is pointer. Yan yung nagli-link sa first block to the next block and to the rest of the block. Tapos, if wala nang data sa next block, magiging null na lang yung output niya. So yun nga, yung example natin dito is yung GitHub. Kung familiar kayo sa GitHub, merong iba't ibang in-store na data, pero lahat sila link. Depende sa pag ginawa ng user, 'di ba? So ang head natin dun is yung first na data na nakastore doon, and the rest of the blocks or nodes, yun na yung magiging modification sa ating head. Okay. Next.
Stack ADT. Stacks are linear data structures which are based on the principle of last in, first out. Ang ibig sabihin daw po ng LIFO is last in, first out, and where data which is entered last will be the first to get access. And dito na po sa stacks are data is kunyari, at kung sino daw po yung nasa pinakahuling, kunyari nagpasok dun po sa data, siya po yung unang lalabas, and sunod po is yung pangatlo sabay. Stacks are prominently used in applications such as recursive programming, reversing words, and undo mechanisms, and in word editors, and so forth. And meron po siyang operations na ginagawa. Una po is push, adding elements. Ano nga ba ang push? Ang push po sa data structure is siya po yung item onto a stack data structure so that it becomes the stack topmost item. And pop. Ano nga ba ang pop? Ito po yung remove an item from the stack, and pangatlo is top, accessing elements. Ang top is yung parang based po dito sa nakita niyo example dito na may push, pop, and top. Ang una pong papasok is na elements ay yung push, and sunod po is yung pop, and pangatlo yung top. And dito naman po sa isa is ito po yung pinaka-example niya. Ang nauuna po dito ang lagi ay yung push. Kasi po yung push siya yung unang papasok pero siya yung huling lalabas. Pero ang huling lalabas naman is yung top. Parang palitan lang po. Push ang unang papasok and top yung unang lalabas. And yung pa-push siya yung deleting elements. And next na pala. Alike and 2. QADT. Q is almost the same as stack ADT. It's only different from stack because Qs are used as network buffers for traffic congestion management, used in operating system for job scheduling and many more. And dito na po sa Q is siya daw po yung parang sa network buffers for traffic congestion management. Siya po yung nag-ooperate, kunyari sa job nga po dito, yung sa mga schedule niya, like dito po sa example na po nandito is, iba naman po kung paano siya Ang nauna naman po dito is push naman, sabay, ang parang, di ba, pag tinulak mo yung example, pag tinulak mo yung table, paunahan, hindi siya pabalik na. Parang push sabay top na dire-diretso na. And next is moreover, it is built using the array structure and as operation which can be performed from both ends of the queue, that is head, tail, or front, back. Kasi dito naman daw po sa queue is meron siyang mga pine-perform like yung head, tail, or front, back. Ito na nga po yung dito na po sa isa. And dito daw po is insertion and deletion happen on different ends. And dito po, nakita po nyo ito yung example na dito is first in, first out. Ito po yung nakita nyo yung front, sabay yung rear, saka yung NQ and the Q. And operations such as adding and deleting elements are called in NQ and DQ and assessing the elements can be performed. And dito naman po sa isang example na to is ang NQ daw siya ang DQ is siya yung ang NQ siya yung adding elements and DQ is siya yung deleting elements. Siya yung nag-access dito na para mag-perform yung parang yung sa ano po sa data. Kunyari, ito yung data. Yung meron diyan mga parang box. Sabay, yan yung data po. Sabay, kunyari, NQ, paganto siya, pa-push siya. Pero pag DQ is, parang pabalik siya. Parang palitan lang, parang paras lang po nung sa may taas niya. And sabi nga po dito is first in, first out. Kung sino po yung unang papasok, and siya din po yung unang lalabas. Hindi po kagaya nung sa isang example, kung sino yung unang papasok, siya yung huling lalabas. Parang palitan na po dito sa stack ADT sa Q ADT. Next.
JP, dagdag ko lang dito sa Q. Di ba madalas natin itong nagagamit familiar tayo dito sa Spotify or sa kahit anong music player. Yung first, kunyari, meron kang pina-play sa head. Tapos pag naglagay ka add to queue, ma-add dito. Tapos magdagdag ka ulit ng add to queue, ma-add dito. And dito. Ito yung front, diba? Dito yung first na pinili mo i-add sa queue. Tas next. So yung last na ilalagay mo, yun din yung last na maa-access. So yun lang.
Trees ADT. Trees are non-linear data structures which have root and nodes. The nodes are the other data points that are available to us. So yung data structures daw po na trees is which they are connected to each other and there's a way to go from root node to every other node in the structures. And also ito din po ay efficient way of storing data and organizing data that is naturally hierarchical. And there are the levels that show the depth of the information, which is the root, child, and the leaves. So as the yung root daw po, the root node, ito po yung node from where the data originates. And as you can see po sa example, yung sa A, B, C, D, and E, F, yung root node po is yung A, which is represent as 0. Then, sinasabi po na yung root node po is a tree without any parent. Yun po kasi, as you can see po, yung A is nag-iisa lang po siya sa taas. And yung child naman po, the node that precedes is the parent and the node after is called the child. So, yung child po, is sinasabi po na ito po yung B and C, which is yung 1 and 2. And the lastly po, leaves, the last node, yun na po yung D, E, and F. And which can be used in a lot of real-world applications such as the HTML pages use trees to distinguish which tag comes under which block. It is also efficient in searching purposes and much more. Also, remember din po na yung trees po, one constraint of something being a tree is that there is no two references that link to the same node. And pag nag-link po yung dalawang references sa same node, nagba-violate po siya ng condition. Next. Hashmap ADT. Yung hashmap ADT naman po are handy data structure for converting one set of data to another set of data. They rely on the doesn't hash function, the modulus function, and a list of bucket to accomplish their goals. So sa hashmap naman po, ito po yung may goal po sila according to their function, and also may modulus function din po siya and buckets. As you can see po, ito po yung hashing data structures po as I example po. Yung hashing naman po is a technique or process of mapping key value into the hash table by using hash function. Hash tables uses a hash functions to compute an index, also called hash code, into an array or bucket or slot from which the desired value can be found. So yung hash table po, ito po yung data stored in an array format where each data value has its own unique index value. Access of data becomes very fast if we know the index of the desired data. They can be used on implement applications such as phone books, populate data according to the list, and much more. Next.
Summary. For large-scale programming, abstract data types or ADTs are essential. They hide internal information by packaging data structures and action on them. The abstract data type can prevent other portions of the program from directly accessing the data representation. And yung nakikita niyo po na different kind of ADT or abstract data type is list, linked list, stack, queue, tree, and hash maps. This is the summary of ADT or abstract data type and the main points of the text. And as you can see, that he has a different types of ADT. And you can also see what happened in the data. He is different in how he is. Flows and what are the important things to do properly connect the data. Yun lang po.
Add ko lang din, ADT helps the program to hide the process na ginagawa nila sa data. So, mas add siya sa security ng program para hindi siya mabilis ma-access ng mga kahit sino. Kasi hindi naman nila nakikita kung paano ini-implement yung data. Yun lang.
True.
That's all from our group. Thank you very much for listening. Again, we are the team. We're the team Paro G from BSIT 1C. Thank you.
Thank you po.
Thank you po.